Hello, everyone. Good morning. Guten Morgen. Great to see all of you. I'm really excited to have the OpenSearch conference for the first time outside North America here in Europe and in Berlin. In Berlin, especially because the search and the open source community here is really vibrant. We are looking to grow the open search community, and we're just getting started here. So good to see all of you. My name's Mukul Karnik. I'm the general manager for OpenSearch at AWS. When I started out at OpenSearch, this was about 2 years back, the OpenSearch project had just gotten started. It was 6 months since the launch of the project, and we were just getting started. I think we had one release, and things were sort of slow to get out of the gate. However, over the last couple of years, we've made a lot of progress. We've had 15 releases of the software, so about a release every 6 weeks. We also now have more than 2,000 contributors that are outside of Amazon and AWS. So really good to see this progress. And we want to continue to grow both the momentum as well as the contributors coming from the community. So really good to see that. Before I get into the innovations that are powering OpenSearch, I wanted to talk about search, which is the primitive or the foundation for OpenSearch. So OpenSearch is an information retrieval system. If you go back to the olden days, even before the era of the computers, you had different ways to retrieve information. So for example, if you're in the library, you would use different cataloging schemes or indexing mechanisms to get information from books. You would use index cards. You would look at the index at the back of a book. And OpenSearch is no different. There's an indexing mechanism, it's called Lucene, where it's an inverted index where you can retrieve information. And that's what makes OpenSearch powerful, because search is the primitive that drives OpenSearch. If you think about it, if you have a catalog of products and you're looking for getting the product that you want, you use search. If you're looking to get errors from a particular log, you'll again go use search, find and filter and narrow down and figure out what the error is and get to your root cause. Similarly, if you're looking for a security issue, again, you'll go use search, go through the logs and try to find this particular root cause. So it's really the search primitive that drives OpenSearch, and that's what makes it powerful. And with AI and ML, we are now seeing that this primitive is becoming more powerful because you can use semantic search and other techniques to find this information more easily and more quickly. With that, let's start with the basics. OpenSearch is really great at text search. If you have, again, a list of products and you want to find the relevant product, what you can do is index your data into OpenSearch. And then when you query, OpenSearch uses the BM25 algorithm to find the most relevant items that are out there in your catalog. Then you can use the different kinds of techniques like faceting and filtering to narrow down the product. A lot of times, the first result may not be what you're looking for, and these techniques are really powerful to help you get down to the result that you're looking for. And that really works really well for about 80% of the use cases. There are about 20% of use cases where the semantic understanding of the data is really important. You need to know the semantic relationships to be able to find the information. So in those cases, this text search-based approach does not work well. So with AI and ML, we have machine learning models that can understand the semantic meaning of the data, and you can encode that in and store it in OpenSearch, and then use OpenSearch's vector search capabilities to retrieve those results that are semantically similar. So this lets you address those 20% of those queries where semantic search works really well and keyword search does not. So let's pick an example. Let's think of the phrase dog grooming. Like, let's say you want to find a place where you want to groom your dog, and so you're searching for the phrase dog grooming. And you search that and you use keyword search. A lot of times what you'll find is either dogs, like images or things related to dogs, and things related to bride rooms, but maybe not the dog grooming thing that you're looking for, which has a different semantic meaning. And hence, you want to be able to encode that both when you're indexing your data into OpenSearch and when you're retrieving that data. That's where vector search plays a really important role. What you can do is when you send your data into a machine learning model, it generates vector embeddings, and you can take those vector embeddings and index it into OpenSearch. Then when this query comes along, the dog grooming query, you generate vectors out of that, and then you are able to sort of do a similarity search in OpenSearch to find the relevant information. And this is really powerful because it helps you address those 20% of queries that a keyword search-based technique does not let you do. This technique is also very helpful to find other challenging problems. For example, you want to find recommendations based on what you like. You can do similarity search in the vector space based on the encodings again. And you can find, for example, your favorite music and music similar to that. So it's a pretty powerful technique and is being widely used in OpenSearch. Now let's look at a sample application, a traditional search application that today maybe many companies are using. It's pretty simple today. You have an application, it calls a database, and you have ingested data into that, and it returns the results based on what the query is. It's pretty straightforward. Now, if you want to incorporate let's say vector search or a semantic search into it, what you typically have to do is you have to build a microservice that calls these machine learning models, generate these vector embeddings, and then you store that in a vector database. And then you're able to answer queries, again, by calling these machine learning models. So you have to build a pretty sort of complicated architecture and infrastructure to start using machine learning. You have to use something like LangChain to orchestrate all of that in the microservice. You have to configure your ML servers to use one of the many LLM models that are out there. And so it's a lot of heavy lifting that you all have to do. So in version 2.9, we launched Neural Search. It simplifies the way you can do GenAI development and using vector search capabilities in OpenSearch. What you can do is you can use search pipelines instead of using the microservices needed to connect to different machine learning models. You can configure these machine learning models within OpenSearch. OpenSearch has native connectors to most of the machine learning models out there, and so it's a matter of configuration. So with just some basic search pipeline code and some configuration in your extensible connector, you can get started. And we are further looking to simplify this. We want to get to a place where you don't even have to write any code. And so there's work going on in the project to be able to get to a place where you can do neural search without having to do any coding. And so that's an exciting sort of innovation that's going on in OpenSearch. So we talked about vector search, we talked about neural search. And as I said, 80% of use cases work really well with just keyword search. So how about getting best of both worlds? What if we could combine the keyword search and combine the neural search? And for the use cases where keyword search works well, use that. And for the use cases where neural search works well, use that. That's what we're doing with hybrid search. We launched hybrid search in 2.10. With that, what you can do is when a query comes in, you're able to send it to the regular index to get your regular search results. You can send the query again to your neural search to get back the results using the vector search and the machine learning models. And then you're able to combine these results using different kind of functions to get the best of both worlds. And this helps you address both like the 80% of keyword search queries as well as 20% queries. And we offer a bunch of flexibility in how you combine those results, and it gives you sort of the power to control your search experience. We have also invested in the sparse vector technique. So if you look at most of the LLM models out there, they generate dense vectors. And they work really well, have high accuracy, but have two challenges. One, that dense vectors generate a lot of vectors, so it takes a lot of space, and it increases storage costs. So if you have a lot of data, it starts becoming expensive. Two, if your application is latency sensitive, most of the embedding models still take hundreds of milliseconds. And so that can be challenging too. So if you're running an e-commerce application, those milliseconds matter a lot. And in that case, the sparse vector technique works really well, where the data is encoded using sparse vectors, which takes less space, and the sparse vector models are much more efficient in terms of latency. And in terms of accuracy, while they're slightly below performance compared to the embedding models, they still do really well. So we highly recommend this for applications that are latency sensitive. Finally, we've also launched multimodal capabilities within OpenSearch. So what you can do now is you can encode images into OpenSearch as vectors. You could do that before too, but let's say you can encode that. But now you can send an image as a query in OpenSearch and get back similar images as responses. So this is really powerful. Let's say you're a manufacturing company and you're looking for a part that is similar to the picture of the part you have, and you can just do that image query and are able to get similar results. So it's pretty powerful technique, a lot of different applications of image search, and is now natively supported in OpenSearch. So now we have regular text search, we have neural search, we have hybrid search, we have sparse vector-based search, multimodal search. And most recently, we also introduced conversational search. So how is this different? What conversational search lets you do is maintain memory of the previous context. So if you have a question that's asked and answer that's returned, OpenSearch can now maintain that context. And for the next query that comes in, you can use that context and answer questions. And so this, again, is really powerful if you're building a chatbot application and you want to maintain this kind of state to help give better experience to your customers and users. So a lot of different ways to do search in OpenSearch, and think of OpenSearch as a search platform where you can build interesting GenAI applications and search applications that can power your website. So going back to search as a primitive, I was talking about search is a primitive that powers search capabilities within OpenSearch. It also helps you find issues and errors in logs. So if you think about log analytics and observability, this search primitive is really powerful. So let's say you have a log, you have a set of logs that you ingest into OpenSearch. You can do anomaly detection on those logs. You can do alerting. You can do different types of queries. So we now introduced a new language called the pipe programming language that lets you query the OpenSearch logs in a very intuitive manner. You can it's a language that's designed to query unstructured data, and you can filter out the results that you don't want and focus on the results that you really care about. We have also extended OpenSearch to support traces. So we support trace spans, service maps as part of OpenSearch. And we've also extended OpenSearch to support metrics. So now you can visualize metrics from Prometheus within OpenSearch dashboards. So it really covers logs, metrics, and traces for your observability use cases. So how does the observability architecture in OpenSearch look like? You have this data prepper component, which is also part of the OpenSearch project. that lets you ingest logs, traces, and metrics. It supports the OTel schema. You can then ingest that into OpenSearch and store these in OpenSearch as indices, and use this pipe programming language that I was talking about to query across logs, traces, and metrics. And this PPL language is, of course, available in OpenSearch dashboards, but is also supported in tools like Grafana. So you can use PPL from all these different places and query all of this data in OpenSearch. So it really gives you the flexibility for using OpenSearch through different ways. One of the areas where we have innovated and delivered at scale is the anomaly detection capabilities. The anomaly detection capabilities in OpenSearch work at millions of metrics. It can also support. It does not require any machine learning training, and so it uses unsupervised techniques to really do the anomaly detection. So it does not require any pre-training and works out of the box, which is awesome. It works using the random cut forest algorithm and is really powerful. If you have not tried it, I would recommend trying it out. And with continuing on the trend of machine learning and GenAI, we are also working on, of course, LLM-based conversation assistant. So here's a quick kind of preview to that.
As a developer, you work to deliver simple solutions to complex problems. As your applications and infrastructure continue to grow, so does the amount of data they generate. Getting insights from this ever-growing data can be time-consuming and requires specialized skills. Imagine if all it took was a simple question to quickly understand what's happening inside your systems. Generative AI is opening up new ways to interact with and discover insights from your data. We're excited to introduce the OpenSearch Assistant Toolkit to help developers build generative AI experiences to solve search and analytics problems. With the OpenSearch Assistant, you can build solutions that let you write queries using natural language, such as, "Are there any errors in my logs?" Or if you want to quickly see your data in action, try asking the OpenSearch Assistant to create a visualization. The OpenSearch Assistant unlocks a new world of possibilities for building powerful generative AI experiences and discovering rich insights from your data. Start building with the OpenSearch Assistant today.
So here's a question for the audience. How many of y'all have tried the assistant or in the playground? Oh, that's a few folks. Cool. Yeah, so the OpenSearch Assistant supports natural language. The way it works is we have built a set of skills. Think of natural language to PPL as one skill, natural language to visualization conversion as another skill, listing out alerts as another skill. So we have built numerous such skills within the OpenSearch Assistant, and then leveraging the power of the LLMs, which are really good at reasoning. We take the question, use the LLM to figure out what are the right skills or tools to use, and then leverage that in trying to answer the question. So I'd recommend trying it out. I'd also recommend adding more tools so that the assistant becomes more powerful and really can help sort of solve some of the issues while you're using OpenSearch. So highly recommend trying that out. You can connect it to any of your preferred models. So if you're using Amazon Bedrock, you can use the Claude model or any of the other models there. If you're using OpenAI, you can use the ChatGPT model. So you can try it out with any of the models out there. One of the other use cases where this search primitive, as I was talking about, is used is to find security issues in your logs. So today, OpenSearch supports security analytics, and the way it does, it uses its built-in rules engine to detect events in your logs and then alert you. We support more than 2,000 types of rules. These are Sigma rules that are available in open source, as well as you can write your own custom rules and detect these events. We support more than 25 different log files, log file types, so you can run these by default on those types of logs. And we support alerting on that as well. So it's a good way to get started on sort of basic security analytics use cases. Finally, we also introduced a correlation engine in the OpenSearch security analytics, where you can correlate between multiple log events. So if you have, say, an access log event and there's something going on in your error logs, you can take that and correlate them and find out what really is the security issue that's going on. So it's a pretty powerful way to get to the root cause pretty quickly. One area that is really important for this search primitive to work effectively is performance. Like, we need it to be performant for the search use case. We need it to be performant for the logs use case. We need it to be performant for the security use case. And for that reason, we are heavily invested in improving performance of OpenSearch. We have, to date, between release 1.0 and 2.12, improved indexing throughput by 25%, reduced latency significantly across a large number of different queries, and reduced storage from about 15 to 30%. What that means is that you can ingest data into OpenSearch more quickly, you can query faster, and you can do all of that much cheaply. So a lot of focus going on in the performance space for us, and this is an ongoing effort where you will see further improvement in performance. If any of you all here are performance engineers looking to contribute back, would love to hear from you, and looking forward to your contributions there. With that, I want to introduce Hari from SAP, who will talk about how they use log analytics in OpenSearch.
Thanks, Mukul. Good morning, everyone. I'm super happy to be here and to share with you how we at SAP leverage OpenSearch to offer a powerful observability service. So in order to make the lives of its customers easier, SAP offers a technology platform to build, integrate, and extend business applications. This is the SAP Business Technology Platform, and it comes with a comprehensive set of tools, services, and runtimes. Broadly grouping, there are three interesting personas that play a role here: the SAP service teams, the SAP platform teams, and the external customers that build business applications on top. Among these three personas, right from the start of the development phase, the need for a hosted observability service is paramount. This is mainly to reduce the operational effort, costs, and focus on the business logic. There is also need to have predefined contents tailored to the runtimes that we offer so they can get started easily. Even within these requirements, there is varying degree of needs from customers to customers, for example, with respect to retention policies, privacies, and encryption needs. So in order to cater to all these requirements, my team, BTP Logging Service, offers a hosted observability service that can cover the needs of all three personas here. All this is powered by using OpenSearch as a backend, and let's take a closer look into how our setup looks like. My name is Hariharan Gandhi, and I'm the product owner of the logging services at SAP BTP. I'm a distributed software engineer with about 11 years of experience, and a major portion of which I spent with SAP's observability needs. I recently became a dad, so most of you could imagine the most significant thing that I search for is sleep. So in the presentation, let's take a look at how our OpenSearch setup looks like, some of the prominent use cases that our users use it for, challenges that we are trying to address every day, and close it with my team and collaboration with OpenSearch community. If I'm simplifying the requirements, on the log shipper side, we have runtime-specific sources like the CF Logaggregator And there are shippers that send from arbitrary sources like Kubernetes containers using agents like Fluentd, and of course the recent OpenTelemetry. With our latest focus shift towards OpenTelemetry, we are even able to integrate beyond the BTP LOB, for example, with central monitoring systems at SAP, thanks to the shared semantics. So on the ingestion side, there is a need to support custom parsing rules for non-standard protocols, and we also use Data Prepper to support ingestion through OpenTelemetry. On top of storing data into OpenSearch, one of our key goals is also to offer predefined contents tailored to the runtimes that is offered by SAP, and also enrich it with SAP-specific correlations. So within our service, there are two types of OpenSearch setup. The first one is large OpenSearch clusters. There are central clusters deployed on virtual machines, and all customers ingest their logs into OpenSearch cluster. We call them application logging service, and all the SAP teams and service teams ingest into a single large OpenSearch cluster. We call them platform logging cluster. And multi-tenancy is built on top of them. If you look at the size and scale of this setup, we deploy such large clusters across the globe in 50 different data centers. And if you look at one of our largest data centers in Europe, Frankfurt, we support an ingestion up to 1 million events per second. So I call it even because we do logs and metrics, and store them for 14 days. So this amounts to approximately 100 billion events that we query on. And if you have to express this in terms of CPU, on the largest landscape, we use 1,000 CPUs and 1.5 terabytes of memory, and half a petabyte of storage, with about 60 to 65% of disk usage. Some of the challenges with this kind of setup is the increasing complexity with multi-tenancy, because it's a shared stack, and it also restricts us heavily to expose all the capabilities of OpenSearch to the customers. So when we started quite about 3 years to build a successor service with OpenSearch, we wanted to go with dedicated stack for each customers. So with that motto, we built the OpenSearch Setup 2, where we provision a complete exclusive logging stack for the customers. So this is only possible if we switch to Kubernetes from virtual machines. And here, in this setup, we see customers draining their logs into their own instance. They can completely leverage the full potential of OpenSearch, and they can add bring their own identity providers and integrate it with OpenSearch. Speaking of numbers, currently we operate close to 7,400 OpenSearch clusters on Kubernetes. So you can imagine this is a stateful intensive workload. So there are close to 50,000 elastic block storage that are attached to these containers, and we ingest close to 5 petabytes of data every month and offer 3 petabytes of storage that will auto-scale. So you can calculate it's about 15 days of retention that our customers are using here. If we want to express that in terms of machines, we are using close to 1,700 Amazon EC2 machines, M6i machines, that amounts to 50,000 CPUs and 200 terabytes of memory. This is possible by deploying them on Kubernetes using open source Gartner, and we deploy it on to 10 different global regions. Now that we have solved the problem of multi-tenancy, we have additional flexibility, we have introduced a complexity in operations. So it is extremely complex to perform day 2 operations, because there are 7,400 clusters, and any issues with them would affect all 7,400 of them. And so this is the new complexity that we want to address. So this is only possible if you have a strong control component that is doing majority of the day 2 operations. So let's look a closer look into a single instance. So for persistence, we obviously use OpenSearch. We start with 2 data nodes, and then they scale based on the disk utilization automatically, and they also scale in with secure evacuation and draining of nodes and then they scale into a smaller number of nodes. For visualizations, we use dashboards. And like I mentioned, for arbitrary sources, we use Fluentd to parse and ingest. Fluentd also scales horizontally based on CPU load. And for OpenTelemetry, we provision 2 data prepper instances. All these workloads are spread across 3 zones, and the data within the data OpenSearch is zone-aware, distributed in a zone-aware fashion. Like I mentioned, we have a control component that is taking care of maintaining the life cycle of these instances, and we also have monitoring component that reports to us the health and usage metrics of every single OpenSearch cluster. Let's take a closer look into the control components. The control component includes a Kubernetes operator, which is similar to the OpenSearch Kubernetes operator out there. And this is responsible for maintaining the lifecycle of the instances, like provisioning them, performing updates whenever there is an OpenSearch version bump, and deprovisioning them. It also takes care of auto-scaling, reads the disk utilization, performs a proper cooldown period, and does the auto-scaling. And from our experience in operating OpenSearch for about 8 years now, we have gained a lot of operations, recommended actions, which are manually executed. We try to translate as much as possible into this operator logic that the day-to operations are done automatically on these clusters. And fourth point is the content upload. The operator takes care of reconciling the predefined dashboards, contents, alert definitions, security configurations, and all of them into these customer clusters automatically. And then we have backup and restore and credential rotations, and all these taken care of by the control components. So it is the control component that helps us to operate at such scale, and we just got started with 2 years now, and we are expecting to grow also very rapidly in this. The last is the monitoring component that takes care of reporting health, and it also sends reports of availability metrics to also customers and SREs, and we also have built-in alerting mechanisms. If we zoom out and look at one of our landscapes, it looks like this. We have multiple Kubernetes clusters, and each cluster hosting multiple OpenSearch or complete logging stack. And our schedulers are responsible for scheduling the next OpenSearch stack into the Kubernetes cluster that is least utilized. Next, I would like to talk about some of the prominent use cases I think most of you could already would associate it with. The first is the log analytics use case with root cause analysis or forensic. The first, like I mentioned, all the services that are hosted on the marketplace of the platform use drain their logs into the system, so they use it for performance analysis of their services. And the next one is the access logs. Even before every request that hits the platform, even before hitting the service, hits the ingress, and it writes an access log. So using the combination of these two, we could infer powerful information. For example, in a use case where there is an API with compromised authorization. So we could use the access logs and have the request correlation from the access logs and check which access log has led to the access of the compromised API, and then use the same correlation with the database service to get the user information. With this, you can either take actions like blocking the user, identify his source IP, and block the IP, and do any such forensic afterwards. The next use case is the service performance and quality. For the workloads that run on our runtimes, we offer out-of-the-box service quality dashboards. We do it through the 4 golden signal dashboards, the latency, traffic, error rates, and saturation. So we do it for both Cloud Foundry and the Kubernetes-based schema runtimes that we offer. So the service teams could use these dashboards as an indicator for their SLOs. The next one, and the next example is used by the global operations team. They drain logs from 50 different data centers that I mentioned into a single OpenSearch cluster, and they use it for a really interesting use case. They enrich the log data so that they can identify stale applications that are residing in the platform. And once they have this information, they try to then free memory by shutting down these stale instances. This is a good example of how enriching logs with additional metadata helps with interesting use cases. Last but not least, with our recent invest in OpenTelemetry, on top of the built-in OpenTelemetry Trace Analytics plugin, we also offer default, for example, container metrics based on OpenTelemetry. We also have JVM metrics for OpenTelemetry Java instrumented applications, and we also have a trace and logs correlation dashboard that easily allows users to pin a particular trace ID and then drill deeper into the application logs to find the root cause. Lastly, I would like to just touch upon some of the challenges that we are facing. Since, like I mentioned, we have 7,000 plus clusters. Parallel upgrade of these 7,000 clusters, be it upgrade of OpenSearch version, or the Kubernetes version, or the operating system versions, it is going to be really complicated. We at several times also hit the rate limiting of either Kubernetes API server or even the infrastructure providers rate limit, because we have to also detach and mount and unmount 50,000 disks. The next point is the shard count or sizing. Since we have auto-scaling based on disk size, it is for us, it's always a challenge for us to find a sweet spot on the shard count and also sizing that we can do effective auto-scaling. So this is one thing that we are trying to address constantly. The third one is the size-based retention. So we offer both age-based retention and size-based retention. But the size-based retention, where we say we want to express if the overall disk utilization with its auto-scaling capability reaches a certain percentage, then delete the old ones. This is not directly expressible via ISM at the moment, so we had to implement it externally. And since we have Data Prepper in production, and it's a relatively new component, we are learning every day the performance, configurations, improvements, and we are collaborating there with the Data Prepper team to also port them back into the productive setup. Last but not least is handling customer misconfiguration. So as an observability service, you can be at two ends of the spectrum. You can either offer an observability service that's completely rigid and offers a contracted set of tools, or you can give the tools to the customers and let them have the complete flexibility. We try to find somewhere in the middle ground, but this causes us to, this poses a challenge that we cannot easily isolate the misconfigurations that are red clusters that are caused due to customer misconfiguration, or something is wrong with our operation. So this is some challenge that we are trying to isolate what is the root cause. Lastly, I would like to close with the community interactions and my team SAP Cloud Logging. So with the kickstart of OpenSearch project, it was a valuable thing that happened to us, that we could continue our service with the open source, OpenSearch, and also we could find a home for our service with OpenSearch that is truly open source and comes with a vibrant community. We also collaborate with community through GitHub pull requests, issues, technical discussions, and collaborations. And we also recently start investing in making FIPS compliance for the OpenSearch core components. On OpenTelemetry, where we invest a lot recently, we did collaborate to contribute for the OpenTelemetry logs, metrics, and traces. We did now a complete performance analysis for the setup that we have, and we also got feedback from the Data Prepper team on what are the best configurations to use. Speaking of which, there is a presentation from my team member Yannick and David from the Data Prepper team that happens, I think, in the same venue at 11:40. I would highly recommend to listen to this session. And last but not least, I'm super glad that one of my colleagues, Carsten, is now a maintainer of Data Prepper open source project. This would help further strengthen our collaborations with the community. Before I hand over to Mukul, I would like to thank for listening. I'm here with two of my colleagues, Penny and Yannick, so I would like to interact with you if you have any questions. Then thank you, and back to you, Mukul.
thank you, Hari and team, Karsten and team, for contributing towards Data Prepper and improving some of the capabilities in OpenSearch. OpenSearch truly is community-powered. We have contributions from Karsten and folks from the SAP on Data Prepper. We have contributions from folks in ByteDance in the KNN plugin. We have contributions from Aryan in the conversational API. So if you look at the conversational APIs, they contributed that. And we have contributions coming from many different community members. We have a member who is a maintainer on the core and is from Ivan. So we're really seeing a lot more community contributions in OpenSearch, and all the innovations that are coming, many of them are coming from the community members that are part of the OpenSearch. So as I said, we have more than 2,000 contributors who are now contributing to the project outside of Amazon and AWS. And we are seeing increase in the number of contributions from the community, and it's a really great sign. So a call for action for all of y'all. If y'all are thinking about contributing to OpenSearch, now is a great time. If you've been contributing to OpenSearch already, now is a great time to become a maintainer on OpenSearch. And we are really looking to grow both the contributor base as well as the maintainer base for OpenSearch. With that, I wanted to take a moment and recognize that we have 15 different maintainers from 8 countries in the EMEA region. We have a few maintainers here in the room. So if you're a maintainer on an OpenSearch project, if you can just stand up so that we can recognize you. I don't know. Any maintainers here? Now, if you've contributed to OpenSearch, we would like to recognize you too. So if you've contributed to OpenSearch, please do stand up. It's OK. We can stand up. I really appreciate all of your contributions. One of the areas where we wanted to be really open was also have a dialogue with the community. And that was really important for us to listen for feedback in real time and also collaborate with the community. To do that, we launched the Slack workspace where anyone can go sign up and start asking questions. If you want to discuss any design or technical topic, you can go there. If you have any things not working, OpenSearch is broken, you can go ask questions there. We have a lot of community members already active there. We now have more than 2,000 people registered on Slack, so this is really awesome to see. If you're not registered there, I'd highly recommend going and trying that out. We are also doing many global gatherings. We have OpenSearchCon in Berlin. This is just the start for this year. We are also looking to have OpenSearchCon in Bangalore in June. This is our first OpenSearch conference in the Asia-Pacific region. And we have, of course, OpenSearch conference in North America, this time in San Francisco in September. I'd highly recommend you all attending it. Hope to see all of you all at least one of those 2 locations. Finally, I wanted to have audience members guess on this. So I know downloads is a vanity metric, but I wanted a few guesses. So how many of you all think we have had more than 100 million downloads? If you can raise your hands. OK. How about 300 million? OK. How about 500 million? OK, that's a few. Yes, we've had more than 500 million downloads, and the number of downloads is growing exponentially. So it's really good to see how all the innovation that the community is driving is helping the project grow and become popular. And it's really growing exponentially, so it's really good to see that. We also have a lot of partners of the project. We have many partners who are presenting or downstairs, so please do attend their booths. They've put in a lot of effort into being here, being present, and of course, contributing to the community. Finally, we are also opening up in terms of governance. So last year, during OpenSearchCon in North America, we heard feedback that the governance was a black box. So to kind of solve that problem, we created a steering committee where members, not just from AWS, but we have members from Logs.io, from Ivan, Oracle, from different companies who are part of the steering committee and help a lot of decisions on OpenSearch. So really good to see that. And I'm really excited about the steering committee and how much progress we are making there. So if there's one message I want you all to take from today's keynote, OpenSearch is open source, and it's all about being open. Open to having more community members, open to having more contributors to the project, open to having more maintainers on the project, and finally, open to figuring out how to drive open governance in the project. So thank you, and great to see all of you.